Yeah, is my screen visible?
Yes, sir, it is feasible.
Okay. So we have 10 questions. Roughly, what we will do is the question will be displayed on the screen, and I'll give you guys 5 to 6 minutes to solve it. And then we'll go through the solution. So the first question involves, it's a three-part question actually. Uh, it is written as three different questions, but we'll see. The first thing is that you are given a function which is defined on r minus 0. So at every point except the origin. And why it is not defined at the origin is clear because the definition of the function involves a term which is of the form 1 by x. It is f of x is equal to sine of 1 by x. So there are four options to this, which I will show later. But what I would encourage you to do right now is try to guess or try to construct the graph of the function and try to describe it to me in some time. So it's 8:04 now. Around 8:07, you guys can take that much time and then get back to me as to what you would think the graph of sine 1 by x is, or if you're sure, just describe it to me, and then we'll go through the options as well. Okay, does anyone have a guess as to what the graph function would look like?
Since the sine graph is between +1 and -1, so it crosses pi, minus pi. So it would cross 0
Sure, that
ideally, but
is,
here we are not taking 0.
yeah, the
So
graph of sine
all,
function is something like this. So it's
yes.
something like this.
So maybe it's not on the point 0. We shouldn't be taking x0
Yeah, this is sine of x.
origin.
Yeah, what is sine 1 by x?
Sir, first of all, we can say that it will be symmetric around, I guess it will be symmetric around origin, right?
What do you mean by symmetric around the origin?
Uh, like just like the graph of sine x,
Sin x is actually not symmetric because sine of x and sine of minus x, they are negatives of each other. So it's actually like an inverse or mirror
Yes,
image.
sir. Yes, sir. Just like that.
Not exactly a mirror image. Okay, that behavior will be there. Yes.
Like sine 1 by x means the waves will be very smaller. I don't think the distance will be smaller. It's close to each
Yeah.
other.
So
And
yes.
it,
So that is what happens. So you know that these are the points where the zeros happen, right? For the sine function, it's at pi, 2 pi, 3 pi, so on. So what will be the points where sine of 1 by x will hit the x-axis?
that would be n pi, like 1 by n pi, where n is natural
So
or
yeah,
integers.
so if I have x is equal to 1 by n pi, then you'll have sine of 1 by x to be equal to 0. Is this okay?
Yes, sir.
So what is the biggest value in this set? So this 1 by pi, wherever it is, that will be, there is no 0 which is greater than that, because 1 by 2 pi will be smaller. 1 by 3 pi will be even smaller, right? So you'll have 1 by 2 pi somewhere over here, 1 by 3 pi somewhere over here, 1 by 4 pi, and so on. So these are the zeros of the function. And beyond that, you will have positivity. So it should be something like this. So it will be an oscillating function like sine. But what happens is that there are infinitely many zeros, because 1 by n pi, as you vary n, you will get as close to the origin as you want. So it becomes denser and denser as you go closer and closer to the origin. And over here, you'll have something like this. Actually, it should, when x goes to infinity, it should go near sine 0. So you'll have something like this. Something like this. And the reverse image on the other side. Is this clear why this happens?
Sir, after 1 by pi, it will never intersect the x-axis, right?
It will not. Yeah.
Okay. And at 2 by pi, it will have the maximum value, right? That is 1.
Yes. That's
Okay.
also true. So if you have somewhere 2 by pi over here, you will have your thing peaking over there.
But as n increases, shouldn't be the value getting more and more less as we are increasing n, as we are going toward the approaching like apart from the origin, the n value get increases. So won't it be like it will get more squeezed as we increase n?
Yes, the zeros get closer and closer. So the sine wave, it's like you're shrinking it, but so over here between 1 by pi and 1 by 2 pi, there is a lot of gap, and that gap keeps decreasing. So it's like a sine wave, but it is squished near the origin. That's what happens. So as you increase the value of n, the value of 1 by x actually decreases. Sorry, the value of x decreases. So I encourage you to think a little bit more about it in your time. So with this analysis, what do you think is the correct graph?
So the second one.
The second one.
Yeah. So here, well, you can use your own system. Use any graphic software and try to plot this and zoom in. You will actually see that uh, the zeros get closer and closer as you get closer and closer to the origin. But at the origin, it is not defined, because you cannot define sine of 1 by 0. So as it is, if you substitute directly, it can't happen. So this is the sine function. This is sine 1 by x. This is sine x. Any guess as to what the other two graphs are?
The first one is x cube.
No,
And
it's not x cube. Because that is
It is
some
not
kind of
x cube actually.
flattered at origin.
Yeah. So if it was x cube would be something like this.
maybe x power. Okay. In that
Yeah,
way,
you
yeah,
can't
it's a
actually
linear.
Sir, I guess we can
guess
say
this is
that
actually
it is the graph of x into mod of x.
x mod x will also have flat at the origin, right?
No, sir.
It'll be something.
Just like that. Yes, sir.
It should be flat. No, it is. It's like one part of the parabola and then another part of the parabola.
Yes, sir. Yes, sir.
X square and minus x square. So this is actually sine inverse x. It is not very obvious to see from here. But if you compare, you can think of this as the reflection about that. Using that notion, you can maybe relate to it. But as it is, you can just guess that it could be this or that. You can't really conclude. And this is sine inverse of 1 by x. I just took some examples just to show you some graphs of some functions. But why is sine 1 by x this way? You can spend a little more time if you have not got it yet. Because as I
Y
increase
becomes
n,
the x-axis.
sorry.
Yeah,
Yeah, if
you
you
are
flip
talking
it, you can.
about the first graph. Yeah.
No. Sine of 1 by x is what our focus is mainly. But yeah, so for the
Okay.
case of sine inverse x, yes, if you rotate the screen and see, you will see a section of the sine function itself.
Sir, at 0, how is it behaving, the graph of this?
The graph of what?
This sine of 1 by x.
Yeah, so in a neighborhood of 0, we can talk about it, right? In an interval around 0. So if you have something like minus epsilon to epsilon, this interval minus 0, you will see that there are infinitely many sine full oscillations of the sine wave that are contained in that.
Okay, sir.
But at 0, what is it that happens? As in, it doesn't really get close to any value. It keeps oscillating. So this is one of the ways in which discontinuity can happen. That is what we are trying to focus on. First, we'll see the graph, then we'll see what happens to the function. So the second question is, well, I've kind of given the answer for it already, but you can give a justification. So it's the question says, is it possible to define f of 0 in any custom number that you want, so that f becomes a continuous function? So take, for example, any discontinuous function which has a jump or just something like this. If you have a continuous function which is defined on, let's say, r minus 0, which is like this, maybe x minus 1 or x plus 1 minus x plus 1, things like that. But at the origin, it is not defined. So there is a way to define it at the origin so that it's a continuous function, right? Whatever this value is, suppose this is at a height 1. If I just define f of 0 to be equal to 1, then I'm done. This will extend it to a continuous function. But can this be done for the case sine of 1 by x? Can you define f of x is equal to sine 1 by x for x not equal to 0 and some c for x is equal to 0, such that this is a continuous function? Is it possible? Take some time to think. We'll resume at 8:21. Okay, any thoughts?
Like I was trying to do LHL and RHL from left hand limit extend to 0 minus sine 1 by x, and similarly for the right hand extend to 0
Yeah,
plus sine 1 by x.
yeah. So if such an f exists,
Then it's continuous.
such a f exists, then because of continuity, what will you have? You should have RHL is equal to LHL is equal to f of 0, which we have called C. So let us take one of them, RHL or LHL. This is 0 plus of sine 1 by x.
That I was not able to solve. So I wrote the entire equation, but not able to solve here.
Yeah, so what is the limit of, okay, a related question. What is limit of x going to infinity of sine x?
That is, I guess, exactly equal to this thing, sine of 1 by
Yeah,
x.
it is exactly equal. Yeah, so but do you not see that sine doesn't really converge to anything? It keeps oscillating, right? So this does not exist.
I didn't got this part.
So if this limit is equal to something, let's say it's equal to c, because it has to be equal to c. No? We want that this is equal to c. This is some fixed real number c. When we say continuous, so there is a sequence argument also. The definition that we had given in the summary session, I will prove it using that as well. But for convergence, or for the limit to be equal to some real number, the requirement is that eventually all the terms are within a small neighborhood of this real number. Right now, if I consider sine 1 by x, it is in between -1 and +1. It is some number.
Yeah, it's an
So if
oscillating
you're drawing
function.
the graph, so if you have it to converge to some real number over here, then if you take any small interval around it, you will have infinitely many values outside it also. So all the values don't come and sit inside one neighborhood, right? Doesn't matter what part of the variable you take, it does not come and settle down near any value between -1 and 1. It keeps oscillating all the time. It is the continuous version of saying that -1 to the n does not converge, right? It has -1 plus 1, -1 plus 1. So it doesn't really stabilize at any point. This
Makes
is
sense.
sort of the discrete case. So this is the continuous case of that. So this does not exist. RHL does not exist. Similarly, you can argue that LHL does not exist also. So this condition cannot be satisfied. So for continuity, what do you require? You require that RHL exists, LHL exists, both of them are equal, and they are equal to the function value at that point. So there are these many conditions that need to be satisfied. But the existence of RHL itself is not happening over here. So there's no talk of continuity. So you can't define the function to be at some certain value at the origin and make it continuous. This is so if you want to look up more of this, you can talk about removable continuity and things like that. You can look that up. Or continuity of first kind, second kind. There are different terminologies around this. But there are different types of discontinuity, jump discontinuity and uh, non-removable discontinuity and all that. We'll not deal with those terminologies, but at least for this function, you see why it cannot be made a continuous function by including 0 in the origin and defining it as some value. We will give now, the third question involves a more rigorous, or as per our definition of limit and continuity approach for the same question. So what you're asked to do is try and find a sequence which consists of all positive numbers. The sequence should converge to 0, but the f of that sequence should converge to c. So you have 4 sample values. C is equal to half, C is equal to 0, C is equal to -1, and C is equal to 1.5. So for which of these values will you be able to construct sequences which converge to, for which the function value, corresponding function sequence converges to this value?
Please repeat
This
the
is
question.
slightly more advanced. Yeah, so what you're asked is, can you construct a function, can you construct a sequence of positive real numbers which converges to 0 such that the function value of that sequence, like the sequence obtained by taking the f of the original sequence, converges to the given real number? And there are 4 cases: half, 0, -1, 1.5. This is a hard question. Take some time, read through it, and actually understand what's happening. So you can relate it with the, I don't know if you were there in the summary session, but there was this rational and irrational 1 - 1 function. We actually constructed 2 sequences, right? One which converges to +1 and one which converges to -1. In this case, I'm asking, for the sine 1 by x function, can I do sequences which converge, sequences for which the function sequence converges to the given options? 8:28, we'll resume at 8:33.
And the function is same, sine 1 by x.
Yes, function as in question 1. So this is f of x is equal to sine 1 by x. In particular, if you can do this for more than 2 of the options, greater than or equal to 2 of the options, it will obviously say that the right hand limit does not exist, because you have constructed 2 sequences which converge to 0 such that the function value converges to something else, some 2 different values. If the right hand limit were to exist, any sequence that converges to 0, the function value of that should converge to that right hand limit.
Sir, should it be 0?
So there could be multiple correct answers to this question. Can you construct a sequence? If you can construct a sequence to 0, okay, that is okay. B is one correct option. You can claim. There could be more also.
Sir,
Yes,
I think -1 is.
-1 is possible. What about half? What about 1.5? What about 0?
Half is also possible because it is between -1 and 1, the range of.
Okay, so what are the answers?
-1, half, and 0.
A, B.
A, B, C.
Okay, the correct answer is ABC. First, let me give you the sequences which converge. So if I want C is equal to half, I want sine of something to be equal to half. Do you know of any value for which sine of x is half? It's pi
930.
by 6, right?
Yes.
So pi by 6 is half, but then you can just multiply it by, add multiples of 2 pi to it. Maybe there are more, but let me just take this. So you have pi by 6, 2 pi plus pi by 6, 4 pi plus pi by 6. This is an increasing sequence, and there are infinitely many terms in this. Now, what I do is I just take the reciprocals of those things. I get 6 by pi, and then I'll just get, I'll not simplify it, but you will definitely understand what I'm trying to do over here. Since the original sequence was an increasing sequence, what is the nature of this sequence? Because we are taking the reciprocal.
Decreasing.
It should be decreasing, and it actually decreases to 0. It will be the sequence whose general term will be something like this. So as n goes to infinity, what happens to this sequence?
It will converge to 0.
It will converge to 0. So this, I'll write that down that way itself. An is equal to 2n pi plus pi by 6 n in n, which we will take the usual convention that 0 is there. So an converges to 0. We have seen that. And what is f of an? By construction, f of an is actually half. So this is a constant sequence. F of an for all values of n is equal to half, meaning it will converge to half. So I'll just write f of an converges to half trivially. So we have found a sequence which converges to 0 such that its function value converges to C. That is exactly what we wanted. But was there anything special about half? Could I have not done the same thing with any value in the range of sine? I can just take one principal value, keep adding 2 pi to it. It becomes an increasing sequence. And take the reciprocal, which makes it a decreasing sequence. And you can easily show that it is decreasing to 0, converging to 0 sequence. And then the f of that value will be a constant. That the function corresponding function sequence will be a constant sequence of whatever value you want. Not only is half 0 and -1, which is the correct answer for the given set of options. 1.5 is not possible because your f will never reach there because it's a sine function. It can't be 1.5. Sorry, could you repeat?
I said it is outside.
Yeah, it's outside the range. So you can't get a sequence which reaches there. So this is the solution. So similarly for B and C. Okay, but instead of just constructing the function, what you have to try to understand, at least at this stage, is that what is happening actually pictorially. I have this +1 and -1, and as we saw, the graph of the function was something like it. There were infinitely many waves, right? So what I'm actually doing is, doesn't matter what value of C that I take, I can take these points corresponding x values, and what I will get is a sequence of values such that the function value is a constant equal to C. That I can always do. Is this clear? What is happening geometrically?
Yes, sir.
Right? So this is like the more advanced version of what happened in the rational and irrational sequence, where we just had two values, which there was the rationals were converging to +1 and the irrationals were converging to -1. But here we have produced something which has sequences converging to any number in the range that you want. So here there are, not only can you find sequences going to two different values, which will say that the right hand limit does not exist. We actually have infinite possibilities. We can, given any number between -1 and 1, I can construct a sequence which is positive going to 0 such that the corresponding function values converge to that given value of C. This is a bit much, and you will not be encountering problems of this difficulty in the course. But since you're looking at it for the first time, it is better to understand things in a way that it's not all equations and remembering formula, right? It's about seeing the picture at least wherever you can. There will be higher dimensional calculus where you can't really visualize things, but at least when you can, you should try to do it. What does discontinuity mean? It's not continuity is not RHL is equal to LHL is equal to the function value. That is just a mathematical formulation. But what actually is happening is the points are not accumulating near something. So this is what you should have, and some prototype examples as to how this can fail and what is the extremal way in which it can fail. If you have this in your mind, there will be a lot more clarity for everything. So that is the purpose of this problem, and I hope it has made sense at least somewhat. You can go back and take a look at this again and try to make more sense of it if you don't already have a clearer picture. So let's move on to the next question.
Sir,
Yeah.
Sir, in that question, I mean, we can take any value between -1 and 1, right? There will be
Yes.
infinitely many values. So,
Yes.
like I understood this part, but like how will we take the sequences that should converge to 0?
That should
Let's
converge to 0. So if you take any value in between -1 and 1, so you have something called sine inverse C, right? So this will be in
Yes.
between -π/2 and π/2. So you take this principal value, the value which is between -π/2 and π/2, and you take the sequence 2 and pi plus sine inverse C.
Okay. So, okay, sir. Just
It's not
figured it is.
exactly that. Yeah, this is, and then you take the reciprocal of this.
Okay, sir. Meaning, just because it is a periodic function, so it, okay. Okay, sir,
Yes,
got it.
yes. So this will be an is 1. What happens if you have this? 2n pi plus sine inverse c. What would f of an be? That would be sine of 1 by x, sine of 1 by an. That would be sine of 2n pi plus sine inverse c.
Oh, okay.
And that's just sine of sine inverse c, which is just c. And what's happening in the diagram is that you're taking that c, you're just drawing a horizontal line, looking at where it cuts your graph, and that cuts at infinitely many points. And there is geometrically you can see that there is a sequence of points which converge to 0. You know, these values, the corresponding x values, which are converging to 0, whose function value is just equal to c.
Mhm. Okay. Okay, sir, got
Okay.
it.
Yeah. All right. So the next function we have is defined as f of x is equal to x for non-integer values and f of x is equal to 0 at integer values. So at what points is this function discontinuous? 8:45, I think we can restart. Try to draw the graph. It will give you a good picture. Any guesses?
Sir, I guess at integers it will be discontinuous.
Not quite. I mean, almost, but there is
Step
one small.
function which are discontinuous at integer.
Well, let me say not all integers. So can you refine your answer?
Maybe except 0.
Yeah, I mean, I guess that's just a guess, no? It's
Sir, because if we like move towards 0, suppose
Yeah,
we are
yeah, yeah.
taking a sequence which is tending to 0, then the
Right.
functional value is also tending to 0 at that point. I
Okay,
mean, the
okay,
points
yeah.
will be dense at 0, the functional points.
There'll be a straight line through 0 itself. In other cases, it is not. Let me draw the graph. So the special points are integer points. Okay? So at these points, the function value is just 0. But what about the rest of the points? It is f of x is equal to x. What is y is equal to x? Or f of x is equal to x? What is the graph of this function?
It's
X minus y equal to
44
0.
degree.
How would you describe this? What is the geometric object?
Straight line.
Yeah, it's a straight line passing through the origin. Its slope 1. So it's something like this. But what happens is at 1, it is not that. And again, it continues to be the graph of y is equal to x. But then at 2, it is not that. And so on. The same behavior continues on the other side as well. So only at integer points, there is a jump. At all integer points except 0, because at 0, coincidentally, the jump is also 0. So do you understand why this is happening? Set of points of discontinuity is integers minus 0. Is this clear to everyone? Why the graph of the function is this way and why the sets of the points of discontinuity are integers minus 0?
Yes, sir.
So this is not quite the step function. Someone else was saying step function. In the step function, what happens is you have things like this and this and this. It's constant in between the sets of the points of discontinuity. In this case, it is actually increasing, right? If you want to prove this rigorously, you can say the right-hand limit will be something like limit as x goes to 1 plus at 1, for example, it is f of x, which is just limit as x goes to 1 plus of f of x is x to the right of 1. So that would just be x. As x goes to 1, it will be just 1. But f of 1 is what? 0 by definition, because it's an integer point. So this and this are not equal, so it's discontinuous. But at x equal to 0, this same argument will not work. You can try it. And at every other point, it's like the function behaves like y is equal to x, the straight line itself. It's a portion of the straight line at every point other than integers. So the set of points of discontinuity is this. So this question should be more or less immediate. You take any of the points of discontinuity of your choice. Doesn't matter which point you take. There's exactly one statement among the 5 given that is true. So which one is it?
Number 4, IV.
Yeah. Anyone else thinks it's not number 4? Any other guesses? All right.
4 only.
Is everyone out? Sorry?
I think it's 4 only. Put everything.
Yeah, and the fact that it is 4 is clear from the diagram as well as from
Yes.
the argument that I was giving earlier. So if I take any integer n, and if I do n plus of f of x, and if I do n minus of f of x, to the right and to the left, the nature of f of x is just as x. So this will be equal to just n. And similarly, I'll have this. This is also equal to n. Both limits exist and they are equal. But this function is not continuous at that integer unless it is 0. Why is that? Because both LHL and RHL exist and they are equal, but they are not equal to the function value at that point. Okay, now, so since this was more or less immediate, there's another question. Question 5 star. Which of the statements above, same thing, is true for f tilde of x, which is defined as step? Everyone knows the step function?
Yes, sir. Sir, step
I assume
means floor function,
Floor
right?
or back.
floor, yeah.
Okay, sir. The
Yeah,
floor
it's
function
floor.
is that
It
is
can be
continuous
either
at
Take some time. Take some time. Think about it and give me an answer.
RHL will exist and LHL will also exist, but they won't be same.
So you're saying it's option 5.
Yes.
What about the others?
yes, sir. Same.
So if you revisit the graph of the floor function, let me take this part. So you have this, something like this. Doesn't matter which integer you take, this is how it will look. So as you approach any integer value from the left, the limiting value is actually equal to, let's say this is n. But if I approach from here, what will be the limiting value of the function?
That is n minus 1.
It should be n plus 1. This is above, right? So
Yes, sir.
LHL would be n, RHL would be n plus 1. If it is too confusing general term, let's just look at this step from 1 to 2. If I approach the function, approach the value from the left, the function value will approach 1. But if I approach from the right, which is from the greater side, it'll approach 2. So LHL is 1, RHL is 2. But what is f of 1 or f of 2? We are looking at this LHL, which is limit as x goes to 2 minus f of x. This is limit as x goes to 2 plus, this is f tilde, right? F tilde of 2. What is the value of the function at 2?
2 only.
This is 2. So LHL is not equal to RHL. RHL is equal to the function value, but LHL is not equal to the function value. So even in this case, there's discontinuity at every integer. In this case, it's actually at every integer. There in our earlier question, there was no discontinuity at 0. So yeah, that's that. Is this question clear for everyone?
Yeah, this question is clear. If you can scroll up, but
The previous question?
no, this question really. So question
Okay, just
3.
a minute. Yeah,
Question 3.
this one, this
Yeah, that one.
3.
So yeah, this one.
Okay, this is
one
4.
only.
Okay, okay.
Yeah.
Hmm.
No, below. If you can scroll down.
Wait, are you talking about 5 then?
No, just we were discussing the question. Yes, this question. So in the
Okay.
previous, just before the step function you said, so I was like I went with the selection of option 5 previously also. Okay.
Okay.
So my approach was that since like they are discontinuous, so LHN and RHL won't exist. So that's the reason I chose 5, sticking to the
No,
previous
RH,
question that we
if they
discussed.
don't exist, you should. Yeah. So this is for the function x at other values and 0 at integers, right?
No, not this. We just discussed now, just the question before this previous question.
Yeah, this one, right? So this is x at r minus z and 0 at z. We're talking about this function, right?
No. This one only, question 5 only. We
Okay.
will explain limit, right hand limit tends to n, left hand limit tends to n. So you selected option 4, which is a correct. But according to me, I choose
Yes.
option 5 because as they are discontinuous, because in any point of discontinuity of function, since the point is discontinuous, so the LHN and RHL won't exist.
Why is
So
that? So in this case, they
why?
do exist, right? So continuous, let me make that clear. Continuous, if and only if the definition of continuity is RHL is equal to LHL is equal to f of continuous at, let's say, x naught,
Correct.
f of x naught. So this is this thing. So there are multiple ways in which this can fail. So if RHL does not exist, I'll write it as DNE. If this happens, discontinuous. So
Fails.
I'll write it as discontinuous if any one of the following. Okay, so one is RHL does not exist. Then this equation doesn't make sense. If LHL does not exist,
Yeah.
this
Same.
equation doesn't make sense. RHL is not equal to LHL. So RHL and LHL exist, but RHL is not equal to LHL. Then this continuity condition is not satisfied.
Hmm.
Or you can have RHL and LHL exist and are equal, and RHL is equal to LHL. This can also happen,
But not equal to f
but
of a.
not equal to f of x. Is not equal to f of x naught. Now RHL meaning LHL also, because in this case they are both equal. So if any one of these things happen, I'm good. And probably you should construct examples where each of the 5 options given is the correct option. So that'll probably help you understand it even better. Construct an example for such that each of the so given any of the statements, that statement should hold for that function. You can these 5 statements that have been written over here. These are actually all the 5 disjoint cases when discontinuity can happen, right? And there is a function for each of those statements. And the given function in question 4, which is this function, happens to be a case where left hand limit and right hand limit, both of them exist and both of them tend to the same value, but the function value is actually equal to 0. The function, as you travel from above or travel
Okay.
from below, approaches
Okay.
this value.
I
But the
forget
function
the
value at that
context.
point,
Okay. Got it.
okay, so
It is not.
you look at this function,
Mhm.
you come from, for example, at x equal to 1, you travel from the left hand side or you travel from the right hand side, and you approach your point of interest, which is x is equal to 1. It approaches this value. The function approaches this value. This happens to be equal to 1 in this case. But the function value at that point is actually 0 because 1 is an integer. Is that all right?
Yeah, got it.
Yeah.
Got it.
Sir, I have a question.
So you can, yeah.
So you may continue. After that, I can ask.
If it is related to this, we can discuss it now itself.
Okay, sir. Actually, I want to know about like how to check the continuity if our function is defined from a closed interval. Let's say, like at the endpoints, how can we check the continuity?
There you'll have only one-sided limit for the endpoints. So you can say it is a function from 2 to 3. Then if you want to check continuity at 3, it is just f of 3 is equal to left hand limit, because you can only approach 3 from this. And then at 2, it is the same thing. RHL at 2 is equal to f of 2. This should happen. So there is a notion of one-sided continuity.
Okay.
Which probably is not there in the course, this course. Usually you take open sets. I'm not going to go into the technical definition of what an open set is, but it is typically, you can think of it like an open interval, where every point has a small neighborhood at least, which is within that set.
Okay, sir. Okay.
But even if you have a closed interval, that would be the most obvious definition, right? You can approach it only from one direction. So you'll make sure that the function value is equal to the limiting value from the only direction that you can approach it from.
Okay, sir.
Okay.
And what we can say about the differentiability there?
Differentiability actually requires that your point be defined in a neighborhood. So usually for the results that are used, at least the very preliminary ones that I can think of, you would say one-sided continuity in the closed interval and differentiability in the open interval. You don't talk about differentiability at endpoints. So
Okay, sir.
just leave it at that. We look at only points for which neighborhoods are there when you talk about differentiability.
Okay, sir.
All right. So this question is once again written in a way which may be slightly difficult to read on first the reading, but just take a look at it. So you have two polynomials, one of degree m1 and one of degree m2. And we are taking the ratio of f1 of n by f2 of n. If you want, you just write down an example, something like n square plus 2n plus 5 divided by n square plus 5n plus 2, something like this. If you want, you can just think of it this way. Now, what would be the limit of this function, which is the ratio of the two polynomials written in terms of n, as n goes to infinity? So there are three cases. The degrees are equal. The degree of the numerator is greater than the degree of the denominator, and the degree of the numerator is less than the degree of the denominator. So analyze the three cases. let me know at 9:10. Let's resume at 9:10. So what's the answer?
Sir, for equal case, if M1 is equal to M2, then we can say that this will be, I mean, the limit will be the coefficient, the ratio of the coefficient of F1n and F2n.
Yeah, the leading coefficient, the first
Yes, sir.
coefficient.
Yes, sir.
Yeah. Okay.
And for second case, it would be just the coefficient of the upper one, the numerator one.
For the second case,
Maybe.
wait. If you have that, okay. So here you're saying leading ratio of leading coefficients.
Yes, sir.
Here it is leading coefficient of F1.
Yes.
And the last one?
That is I am doing now. Maybe take
Okay.
some.
Does everyone agree with first and second? Has anyone else done first and second?
If F1
I
and
think
F2 are
the
same degree polynomial, then we will get the equal coefficient.
I think for the third the equation of F2.
Sorry, your voice is breaking. Could you repeat?
So I said that for the third option, the leading coefficient of F2.
Let's see. Let's take examples first, and let's see how to generalize that to a general polynomial with the given conditions. So we'll take the same thing. What had I written? So this, just for the sake of clarity, I'll just take something like this. So how does one go about calculating the limit as n tends to infinity of this?
We can divide by n square.
So yeah, this is a common class of questions that is asked where you have polynomials in the numerator and the denominator, and what you do is take limit as n tends to infinity. You take n square or whatever the degree of the polynomial is, you take that as common. What you get is this. And the same thing you do for the denominator. So this gets cancelled out. So you have rewritten the ratio of polynomials as a polynomial in 1 by n in some sense. But what do you know about this, let's say 2 by n? What is the limit as n goes to infinity of 2 by n?
0.
That
This is 0. So the limit of this is 0. Similarly, the limit of this is 0. And the limit of this is 1. So their sum has limit 1. The limit of the numerator is 1, right? Limit as n tends to infinity of the numerator, num means numerator, is equal to 1. What is limit as n tends to infinity of the denominator?
Two.
By the same argument, it's 2.
Yes, sir.
So you're multiple times just using the properties of limits of sequences. If you have two sequences which converge, their sum converges to the sum of the limits, and then you can take the ratio as long as the limit is not equal to 0, and so on. All of these things, you're just combining them, using them multiple times to get that limit of as n tends to infinity of n square plus 2n plus 5 divided by 2n square plus 3n plus 7. This is equal to 1 by 2. So 1 comes from the numerator and 2 comes from the denominator. But what did they actually come from? What was 1 and 2? Those were the leading coefficients. In general, if you have limit as n tends to infinity of something am x to the power, let me call this am1, x to the power m1, plus so on up to a1 x plus a0. This is what a polynomial would look like, correct? but here it is n. So instead of x everywhere, I will have n. Divided by what we have assumed is that the degrees are the same. So you'll again start with m1 degree only. The coefficients can be different. You have something like this. What would you do over here? You take n to the power m1 as common, and what you will be left with is am1 by bm1. Is this clear?
Yes, sir.
So in general, if m1 is equal to m2, then it is ratio of the leading coefficient. Leading coefficient of a polynomial means the coefficient of the highest degree term.
Yes, sir.
So that's what happens. So this is correct. What
Sir, for
about if m1
the
is greater than m2?
sir,
Let's
in
take
that
an example
case,
itself again.
doesn't exist actually the limit.
Yeah. Let me just take something like this. We are trying to see what the limit of this is. If we do the same trick or the same approach, what you will get is n square times 1 plus 2 by n plus 5 by n square. And in the denominator, you have n times 1 plus 2 by n. Now, this part goes to 1. What did I do? I did something wrong. It should be n times 2 plus 1 by n. Okay. So in the denominator, that part goes to 2, just as we did it in the first case. The denominator goes to 2. But what about the numerator? This part in the numerator goes to 1 again, but there is another n. So that actually blows up. That becomes arbitrarily large. So this limit does not exist. Is that okay?
Yes, sir.
So this is actually wrong. Here, does not exist is the correct answer.
And for the third one, that should be 0.
Let's see. So I'm not going to do the general case for the second one and the third one because it's similar. So in the numerator, you'll be left with something because the degree is higher. Okay, and the third one was the numerator has lesser degree. So we'll just take the reciprocal of that. So what happens in this case is if I do the same separating the taking out the biggest degree out, I'd be left with something like this. Now in this case, this part goes to 2, this part goes to 1, and the sequence 1 by n goes to 0, right? So you have limit as n tends to infinity 1 by n is equal to 0, limit as n tends to infinity 2 plus 1 by n divided by 1 plus 2 by n plus 5 by n square. This is equal to 2. Right? Once again, I'm using some ratio and all that. So if I have these two things separately, then their product will be the product of the limits. Therefore, this will be equal to 0. Is that okay?
Yes, sir.
And this should also give you an idea as to how to approach the general case. You will be left with some power of n in the denominator, which will converge to 0, as in 1 by n to the power something will converge to 0, and then you'll have a convergent sequence as the remaining part. So their product will converge to 0 anyway. All right. And this is a common sort of question where you are given two polynomials, the ratio of two polynomials, and find the limit as n tends to infinity. The common trick is to remove the n part and remove the degree of each of the polynomials and then look at what is removed. So the next set of questions, the next 4 questions should be, not all of them, but at least some of them involve calculating limits of functions which are of the form f of x by g of x. Typically what happens is if you substitute the limit into that expression, okay, if you don't have any problem with that, if you substitute and get a good answer, then that itself is the limit. But if not, then you have to do certain tricks. There is no one trick which works for everything, but we'll take a look at some of them. One of them will actually be introduced after differentiability in week 8 that we have not covered yet. So we'll not be using what is L'Hopital's rule. Probably some of you already know what it is, but we are not going to use that. We are just going to try to use the laws of limits and compute this. So take some time, 9:25 until 9:25, and let me know what the answer to this problem is.
It should be 2, sir.
Let everyone get done with the solution. Let's, even if you get the solution, it's okay. Once I ask for it, you can let me. Yeah, what is the answer?
1/2.
1 by
Yeah. Why is it 1/2?
Sir, you can like in the numerator part, you can divide x and multiply x, And similarly, in the denominator part, you can divide 2x and multiply 2x.
Yeah. So what we are using is introducing another variable which along with which you can use known identity, and then use the fact that the ratio of limits of two functions is actually the limit of the ratio of the two functions, provided the denominator is not going to 0. No, this is what I have done is just divide both the numerator and denominator by x. But since I want something of the form sine of some argument divided by that same function, I'll also introduce a 2, which again I count for by multiplying as well. So I know that this thing goes to 1, that is given to me. And I know this thing also goes to 1, that's also given to me. That not directly given, but it follows. So the limit of the ratio, so this limit as x goes to 0 is the same as limit as this x over here, which is just. But what happens if you directly plug in 0 in this expression?
That will be in 0 by 0 form.
It will be in 0 by 0 form. So direct substitution doesn't work over here. Instead, we converted it to a form for which we know certain identities. So once you're done with week 8, you can come back to this and see that you can also do this using L'Hopital's rule. Both are differentiable functions and so on. Okay. But even that is not required if you know these identities. You can just reduce it by the division rule for things. Now take a couple of minutes and let me know what the answer to this is. So here you are given a function which is again of the form f of x by g of x. Both f and g are polynomials in this case, but there is one unknown which is written as c, and we have to find the value of c for which the limit of the function exists. Any guesses?
X is equal to 2.
Sir,
X is equal to 2, is it?
It's equal to 12.
X is equal to 12.
Sir, we need to find the value of c. So c should be
Oh,
equal
sorry, yeah,
to
This
sorry,
should be
yeah.
12.
C 12, and there was another C is equal to 2, is it? Okay, let's see. So what's the approach? What happens? What do you observe when you substitute the value?
the denominator is like that becomes 0.
Denominator vanishes. Now, what happens if you have a function of the form f of x by g of x, and let's say you want x going to x naught, and g of x naught is equal to 0, and f of x naught is not equal to 0. It is some other constant.
Then in that case, limit doesn't exist.
Yeah, so
It,
the limit will not exist because the numerator will be tending to some finite value, but the denominator keeps decreasing, right? So provided this is a continuous function and all that, which it usually is, and you're given some question like this. So if you have given the ratio of two continuous functions, if the numerator tends to some finite value, non-zero finite value, and the denominator tends to 0, it means that the ratio keeps increasing, right? As you approach the point, the numerator is some c naught or x or f of x naught, which is non-zero, but the denominator keeps decreasing. So the ratio will shoot up, will blow up. So this limit will not exist. The only way for the ratio of two functions to exist when the denominator goes to 0, the numerator also has to go to 0. So this is what is written over here in the right line. So if you have limit of g of x is equal to 0, then if limit of f of x is not 0, then the ratio does not have a limit. But if this is equal to 0, then there is a possibility that this limit may exist. There might be cases in which that limit does not exist, even in that case. But if f of x naught is not equal to 0, then there is no chance. So what we require is that the numerator at the limiting value, which is 3, we need f of x naught to be equal to 0. So in this case, it is 3 squared minus 7 into 3 plus c is equal to 0 is what we want. And if I simplify this, what will I get? So this is the correct answer. I just erase it. All right. Is it clear what we are trying to do? So if the denominator is 0, the only way for, if on substitution, if the denominator is 0, the only way for the limit to exist is the numerator also should vanish. But c equal to 12 only may be giving you a limit. So you have to actually verify that this actually leads to the case where the limit exists. Does the limit exist for this function as x goes to 3? So that's actually the next question as well, I think. For the value of c obtained in question 8, find the value of the limit. So whenever you have a polynomial and you know that the value of the polynomial is 0 at some point, which means it is a root of that polynomial, right? 3 is a root of both the numerator and the denominator. Is that fine for everyone? We have chosen the value of c such that f of 3 is equal to 0 and g of 3 is equal to 0. I'm writing this as f by g. But what does a polynomial equal to 0 mean? This would mean that the numerator can be written as x minus 3 into something, and the denominator can also be written as x minus 3 into something. And what is that something? In the numerator, what is it?
x minus 4.
X minus 4.
And in the denominator, what is it?
X minus 2.
And what is the answer then? So this I can cancel out because we are not at 3. We are approaching 3. So x minus 3 is a non-zero number over here. So I can cancel it out. And when I substitute, now I can substitute, right? I've removed the part where
Yes, sir.
which makes the substitution fail. So this will just give me -1.
Minus 1.
And that's the answer to question number 9. Is this clear for everyone? This is also another common pattern of questions where you are given two polynomials and you are asked to find the value of the limit. And typically you can factorize them and get rid of the term which appears in both the numerator and denominator, uh, which would actually equate to 0. Okay. So the last question for the session is the following. This is not exactly f by g type of question, but find the value of a1 and a2, if at all possible, for which this is continuous. 940. At 940, we resume. Answers?
Sir, A1 and A2 both should be 3.
Any other answers? No other answers? Does that mean everyone agrees, or has no one else figured out how to do it? Okay, can you tell me why A1 and A3 both are 3?
Sir, like we can find the right hand limit at x equal to 0. I mean, this
Okay, let's
function
do right hand
since
limit first.
yes, sir.
Yeah. What is right hand limit?
That is going to be 2 divided by
Yeah, so how am I going to calculate this?
sir, we can find the limit of e to the power 1 by x when x tends to 0 plus, and so
Yeah,
that is
what is that
actually
equal to?
that is a very large number. Like 1 by x tends to infinity. I mean, if x tends to 0. So e to the power
X
infinity, we
tends to
can
0
say,
plus only, actually. So that's the point I'm trying to emphasize on. So here e to the 1 by x, since we are approaching from right, it will approach 1 by x will approach positive
to
infinity,
0. Yes, sir.
right? So
To
if I look
positive.
at the graph of 1 by x, what is the graph of 1 by x? It will look like this, right? This is the graph of 1 by x. So when I'm approaching from the right, when I'm approaching 0 from the right, the value of 1 by x is very large, or tends to infinity.
Yes,
So
sir.
e to the power that also goes to infinity. So this is actually this one. But then if I take the reciprocal of that, that will go to 0. So limit as x goes to 0 plus of 2 by or whatever by 1 by x will be 0. And I have a plus 3. This is equal to 3. Has everyone understood this part? I couldn't hear you. Could you repeat? Is you
Yes,
understood?
sir.
Okay. And this should be equal to, because you want continuity, this 3 should be equal to f of, what was it? The point was 0. F of 0, but f of 0 is given to be a1, I think. Or a2. Was it a1 or a2? That was a1.
Yeah.
So a1 is 3 is done. The other thing that remains is the left hand limit. So the left hand limit is e to the 1 by x plus a2. The limit of that. So what changes over here? We said that as x goes to 0, e to the 1 by x goes to infinity. So this should not exist unless we are missing something important. What is the thing that I'm missing? So if I give the argument that, so here we saw that e to the 1 by x goes to infinity. So this limit should not exist. What is wrong with this argument?
Sir, actually, just because x is a very small number, which is a negative also, uh, so then this e to the power, let's say h is tending to 0, and we are like this part will become 1 by e to the power 1 by h. So e to the power minus 1 by h, that means 1 by e to the power 1 by h.
Okay. Yeah, so you're saying the correct thing. So the mistake that the argument that I said was this: here we are approaching from the right, and here we are approaching from the left, and those two things are not the same. Here, my value is something very small but negative. So when I take some very small value but negative, this thing is a very large negative value, right? So this goes to minus infinity, as is evident from this graph also. This is the graph of y is equal to 1 by x. So if I approach from the left, I go to negative infinity. And what is e to the 1 by x? The end behavior of e to the 1 by x, what is it? Or e to the x in general looks like this thing. So if 1 by x goes to minus infinity, what does 1 by x go to? E to the 1 by x go to?
0.
This goes to 0. So that first part is 0, and the second part is a constant. So this is actually equal to constant. And this should be equal to RHL as well as the function value, which is A1, which is 3. So you get A1 equal to A2 equal to 3. Is this clear? So this is another class of questions where you are given a three-part function, one defined one way at the point, and then greater than or equal to that, greater than that point, less than that point, it has different behavior. And with the assumption of continuity, you have to figure out some unknown parameters for the function. And the central idea, as we did over here, was to consider the right-hand limit, the left-hand limit, compute them correctly, equate them, and equate them to the function value as well. Is that okay?
Yes, sir. Sir, here, like we have checked, so in the question it is asked that if f is continuous or not, right? So we have checked at 0 only. So what about the other points? Like how can I make sure
Ah,
that at
okay.
other points
For
it
the
is
other
continuous?
points, so probably you will see it in the week 8 content, that if you have a function that is, if you have two functions, their sum, their product, their quotient, if it is not 0, if the denominator is not 0, all of these are continuous functions. So what is this? This is 2 divided by e to the 1 by x. 2, the constant function 2 is continuous. 1 by x is continuous. E to the 1 by x is continuous. And e to the 1 by x never becomes 0. So then plus 3. 3 is also a continuous function. So you're doing all these basic operations on continuous functions, making sure that denominators are not going 0. The resultant function will be a continuous function. So this follows directly from that property. So in the interval 0 to infinity, open, this is a continuous function, follows directly from that. In the interval minus infinity to 0, which is to the left of 0, once again e to the 1 by x is a continuous function, plus a3 is a constant, a2 is a constant function. So the sum of them is again a constant function. So there also continuity is guaranteed. The only problem point is possibly x is equal to 0. That is why you have to test it there. Is that okay?
Yes, sir.
All right, that brings us to the end of the session. If you have any doubts regarding these questions or any other questions that you have, feel free to ask them. Okay. If not, then we'll call it here. Thanks for joining. See you next time. Bye-bye. Good night.
Thank you, sir.